Good afternoon, everyone. Today we are going to discuss about how to find a largest and smallest number in a series. For example, if you store six different numbers in an array, the aim is to find largest and smallest number in a series. That is some set of logic is available. I will explain first how to find largest number in a series. Then I will discuss how to find smallest number. And finally, I will tell you a combined program how to single program to find both largest and smallest number in a series. I will share my screen now. Okay. I hope the screen is visible to everyone. Okay, it's fine. Program to find largest and the smallest number in a series in 8 through 86. We will discuss program to find a largest and the smallest number in a series. Okay, by using 8 through 86 programming. For example, if array contains if array contains number 30, 50, 20, 10, 11, 16. So you want to find which largest number in a series of numbers. For example, if you want to find largest number means we have the separate logic for logic to find largest number. Similarly, if you want to find the smallest number in a series means there is also some logic is available to find smallest thing. Logic to find smallest number in a series. I will explain these two, and then I will tell how to do both comparisons. Both comparisons to find both largest and single program to find both largest and smallest number in a series, and I will show the outputs in EMU 8086 simulator. So you will get idea how to find largest and how to find smallest in a number of series of numbers. I will go to next slide. First logic you will see find the largest number in a series. In a series, okay. First, the concept here is you will need to follow these two different steps to find the largest number. First thing it is largest number. First one is compare AL with SL. These are the two different registers which have some numbers. Okay, by comparing those two registers, we will get logic how to find largest number in a series. If carry is produced, if carry is produced, um, copy copy the value from SI register to AL register. Second step is if no carry, increment. If no carry means simply increment SI and decrement and decrement CL. So here CL stands for counter. Counter. How many times you want to check? Compare AL register value with SI register. If carry is produced, simply copy the value from SI register to AL register. If no carry, increment SI. Increment SI means you will go to the next address location and do the same comparisons again one more time and decrement the counter. So counter will help you to understand how many numbers you want to compare, how many times you will need to compare the numbers with SI with the AL register. So after comparison, you will need to store the result with AL register. Now I will tell what is the logic and how to find largest number in a series. Okay, just remember these two different steps. It is very important to find the concept called finding the largest number in a series in 8 through 86. Compare the register AL with SI. If carry is produced, simply copy the value from SI register to AL register. If no carry, increment SI and decrement CL and compare the next numbers. Okay. See here, first I just initialized all the variables. Initialized all the variables. Array means array is a name which stores the numbers one by one. So it is of type data byte. It can store a maximum of 8 bits. So how many elements you want to compare? For example, if you want to compare six different numbers and you want to find largest one from out of six, so here number of numbers you want to compare here is six. I assign it to the array. Okay, then duplicate. DUP stands for duplicate 00H. Initially, I assigned all the six elements with the value 00 because I want to get the value from the users. The user will type the numbers in the keyboard. So after getting the numbers one by one, I want to store with the different registers. I want to store all the numbers in SI register. I will tell how to store numbers in SI by using this array. Then LEN stands for length. Length determines the maximum number. How many numbers you want to compare. So the length will determines the maximum number in a series. If you want to compare six number means the length will be six. Similarly, if you want to find you want to compare 10 different numbers means length here is 10. Here I want to compare six different numbers and then I want to find largest one. So the maximum length of the array here is 6 and length here is 6. Then I assign the highest initially as highest as 00. It is one type of input parameters which will help you to compare the numbers with they compare this two different value with the number entered by the user. If user enters one by and all the numbers one by one, for first number, second number, third number, fourth number, fifth number, sixth number. If you want to compare, if you want to go for highest number means you want to compare the higher this value with the value stored in the array one by one. So after comparison, you will get the result. So now to do the comparison and to find the largest number, I just initialize the input parameter highest with 00H and the input parameter lowest with FFH. So if you want to find largest number, and I assign the parameter highest with 00H. If you want to find lowest number means I assign the lowest parameter with FFH. Why I mentioned 0 here is if you mention any value with the alphabets means a microprocessor will consider this as a variable. So in order to consider, not to make this as a number, you need to initialize with the zeros. Otherwise, this FF will be considered as a variable. To convert this variable into again number means just simply add prefix with the zeros. So this will be considered as a number. Okay. First, I will say the logic how to find largest number. See here, we have the counter, we have the length of the array. Length of the array, I just assigned to the register CL. This will store the maximum number of that means maximum numbers in a series. I define the length here as 6. So initially it is 6. and then it will goes to 5, 4, 3, 2, 1. So why it is decrementing means I am adding the numbers one by one. Okay, first I added number 40, then after adding the first number, the counter will be decremented by one value. Then after entering the second number 30, the counter will be decremented by one more value. It will go from 5 to 4. It will change from 5 to 4. So after adding the third number, the counter will be decrementing from 4 to 3. So after adding the fourth number, the counter will be decrementing from 3 to 2. Fifth number, counter will be decrementing from 2 to 1. After adding the final number, counter will decrementing from 1 to 0. Now the CL value here is CL value after adding all the numbers in the SA register. Now the counter value goes to 0. After adding all the six numbers from the users, counter value will be decrementing and finally it goes to 0 value. Okay. Now I assign the value for AL register as a initially as 00. It's mainly to find the largest number. Okay. First thing here is first refer this code. First refer this code. This code is mainly used to add and to store 8-bit number one by one from user. For example, if user enters 40 means 40 means this will be stored with this will be stored to the register SA. Okay, I hope you know how to get our program. For example, program to get 8-bit number one by one from users. I created already one video how to get numbers 8-bit number one by one from the users. For example, if user enters one 8-bit number in the keyboard means, but keyboard will not give the exact 8-bit number to the processor. It will give only the ASCII equivalent for the 8-bit number. So, but the processor will not understand the ASCII equivalent. If you want to convert the ASCII equivalent number again back to the original number, we need this set of codes. This set of codes will help you to get 8-bit numbers one by one from the users after entering in the keyboard. For example, from users enters number 8-bit 8-bit number. For example, 40 in the keyboard. But keyboard will not give the number 40. It will give only the ASCII equivalent for number 40. So this will, if you enter 40 means this will give only the ASCII equivalent for 40. But processor 8086 processor will not understand the ASCII equivalent. Will not understand ASCII equivalent. To convert the ASCII equivalent number again back to the original number, for example 40. The original number entered in the keyboard here is 40, but keyboard will give only the ASCII equivalent. If you want to convert the ASCII equivalent number again back to the original number, we use this set of codes. So after entering 8-bit number, the processor get ASCII equivalent. In order to convert the ASCII equivalent again back to the original number, we use this set of instruction. I already make one video how to get 8-bit numbers one by one from the users with a separate video. Kindly refer that video. You will get idea. Finally, the result will be stored in the AL register. You will get the 8-bit number value in AL register after converting the ASCII number again back to the original number. The number will be stored in the AL register. This program will be used along with the original program. For example, if you want to find largest and smallest number means this set of code will be used along with the program to find largest and smallest number to get 8-bit number one by one from the users. So after getting the first 8-bit number, the result will be stored on the AL register. This will be given as input to the program. Finally, it is assigned the 8-bit number to the AL register after getting from the program. This will be assigned to SA. First, this will be assigned to SA. After entering 40 in the keyboard, the value 40 will be moved to the SA register. SA register will be available in the data segment. Yeah, it is pointed by source index register. If you enter 40 in the keyboard, it will be stored in the first memory location. So if you enter second number means this will be stored in the second memory location. Now the pointer will be moved to this place to this place, SA. Then third number, fourth number, fifth number, sixth number. So if you add the numbers one by one, the SI pointer will be incrementing one by one and store the result in the array. Array means memory locations in the data segment because data segment will hold the data. So after the user enters the value in the keyboard, this data will be stored in the data segment with a different memory location. I already told each memory location can able to store only 8 bits. So if you enter 40, this will be stored in the first location. The second location it will store 30, then 20, 10, 9, 20. These numbers are the example numbers. It can be any 8-bit number. So after adding each 8-bit number one by one, the SI pointer will be moved on incrementing for every addition of 8-bit number to the array. This will be incrementing one by one. That's why after first number is entered, this will be stored in the AL. It will be moved to SA register. First number is stored. After that, what I mentioned here, increment SA. So it will move to the second address location. Here, after enter the second number, this will be stored in the second address location. So after the work is done, this will be again the user enters third number, the SA will be incrementing and counter will be decrementing. So adding first number, I just incrementing SI and decrementing the counter from maximum value to the next number. It will change from 6 to 5. After adding the second number, it will be counter will be decrementing from 5 to 4. After adding third number, counter will be decrementing from 4 to 3. By simply decrementing the CL register, we can able to add the numbers one by one in the SA register. So this is the procedure how to add numbers, 8-bit numbers one by one from the user to the array. Just simply move SI comma AL. This will simply move the value from AL to the SI and increment to next memory location. Add second number. After adding, the SI will be incrementing parallelly. Counter also will be decrementing. After the count reaches 0, this instruction will terminate because maximum it can able to store number here is 6 numbers. So after adding 6 numbers, counter will go to the 0. That is here register will be goes to 0. We check for the condition. Jump with no zeros. So now the CL after adding 6 numbers, what is the value for CL here? CL goes to 0. It will check for condition. Jump with no zeros. This will go to the subroutine BK1 to add the next number one by one to the array. So after adding all the 6 numbers, now the counter value becomes 0. It will check for condition, jump with no 0. But here counter is 0. It will not go to the subroutine BK1 to add the next number to the array. So because we add all the numbers, 6 different numbers in the array, there is no numbers to add further. So this instruction stopped executing. After adding all the numbers, CL goes to 0. It will check for condition, jump with no zeros. This condition fails. This will terminate executing it can't go back again to the subroutine. All the numbers are added successfully. Next, here is the program to find the highest number in the array. These are all the numbers. We want to find which number is greater in this array. Array means it contains all the data entered by the user in the keyboard. First user enters 40, then 30, 20, 10, 9, 20. We will need to find which one is higher in the series. First, the logic first I will explain, then we will go to the program. Okay. First, I assign the value for AL register as 00. See here 00. I will compare the number 00 with 40. This is the first number we will compare. First number in the array is 40. I want to compare the number AL with SA. AL register with SA register. I simply compare AL with SA. Comparison means what? Comparison um, comparison between AL comma SI means what? By just simply subtracting comparison by just simply subtracting the value of AL with SI. Comparison by simply subtracting the value of AL with SI. For example, if you subtract smaller number, AL is 00, it is smaller number. If you subtract 00 with a higher number, what AL is less than SI. See here, AL is less than SI. If you subtract any smaller number with bigger number, that is a presence of carry. That is presence of borrow. If you subtract a lower number with a higher number, that is a presence of borrow. If hence carry is produced. See here, condition is compare AL with SI. Compare AL is less than SI. So if you compare means simply subtracting the lower number with the higher number. If you subtract lower number with a higher number, there is a presence of carry. That is borrow is produced. If carry is produced, see the first condition here. If carry is produced, copy the value of SI register to L register. Okay, I just simply, if carry is produced, so I just simply copy the value from SI register to the register. This is the first logic we need to follow. If carry is produced, simply copy the value of SI to the AL register. I copied the value from SI register to AL register. 40 I copy to AL register. So next, increment SI. After comparing, after changing the numbers, then increment SI. The first initially SI is pointed by this location. Now the pointer goes to next address location. This will simply compare the next number with the AL register. Compare 40 with 30. Which number is greater? AL is greater than 30. So if you subtract, comparison means what? Simply subtracting this AL register value with SA register value. So 40 is higher number, 30 is smaller number. If you subtract higher number with the lower number, there is no carry. Because if you subtract higher number to a lower number, there is no borrow. Because if you subtract higher with lower, there is no carry. So what is the condition here? If no carry means increment SI and simply decrement here. Okay, I just incrementing the value for SI. I will not copy the value from SI to the AL register. It will hold the same value. Whatever the value present previously, this will be simply copied to the next AL register. Okay. Now compare third data. Compare 20 with 40. Compare this one is AL, this one is SI. Compare which one is greater. AL is greater than SI. Subtract 40 minus 20. Because subtracting the higher number with lower number, there is no carry. No carry means just simply hold the previous value. No need to copy the value from SI to AL. Simply hold the previous value. Then compare the fourth number, 40 with 10. Which one is higher? AL is higher, SI is lower. If you subtract higher number with lower number, there is no carry, there is no borrow. Simply hold the previous value. Then compare AL with SI. What we do, we just simply incrementing the SI one by one, every location. SI, so parallelly, counter will be decrementing from 4 to 3, 3 to 1, 2 to 1 after every comparison with SI. Okay, now compare 40 with the 9, AL is greater. So if you subtract higher number with lower number, no carry. So no carry means simply increment SI and decrement CL. SI will be incrementing to this position. CL will be decrementing from 2 to 1. Compare this value with 20. Which one is higher? AL is higher. If you subtract higher number with lower number, there is no carry. So simply hold the previous value. Now the counter SI will be decrementing and CL also decrementing. Now the counter will goes to 0. So we compared all the numbers. Finally, what is the number you got? This value will be stored in the AL register. 40 is the highest number. Compare this original number 40, 30, 20, 10, 9, 20. Which one is highest? 40. After comparison and check for condition. If carry is produced, simply copy the SI value with the AL register. If no carry, just simply hold the previous AL value to the next comparison. Finally, I got the answer as 40. This is for now the answer is 40. What is the highest number in the series? This logic we will need to use for any largest number. We will need to use this concept with instructions. Okay. See the calculation. These steps will be used to find these instructions. We will use to find the highest number. That is largest number. Highest number. First see LEA means load effective address. I just loading the array. Array contains the six 8-bit numbers. I assign the offset address of array to the SA register because SA will be pointing each numbers in the array. So if you increment SA one by one, you can able to compare each number in the SA to the AL register. So assign the offset address of array to the SA. LEA means load effective address. This will simply help you to load the offset address of array to the SA. So now the SI will hold the address of all the data in the array. First, it will locate the first data. So after comparison, this will be moved to second location. So after comparison, this will move to third location, then fourth, fifth, sixth, seventh. Likewise, it will be incrementing for every comparisons. So now to do the comparison, first I assign the offset address of array to the SA register, then move CL command length. What is the length value here? See the introduction length. I assign it as a type data byte. It can hold 8-bit data. The maximum numbers I want to compare is 6 number. So now I assign the value for CL is comma length here is 6. Now I assign the maximum count value is 6. I assign to a CL register. See here, length of the array assigned to a CL register. After each comparison, AL register comparison with the SA register, the value for count will be incrementing by one value. After each comparison of AL value with SA, the SA will be incrementing, the value for counter will be decrementing. So after the counter becomes 0 and the comparison will be terminated, finally you will get the largest value. See here, CA will access a counter. Assign this register with length. This will hold the maximum value to compare 6. Move AL comma highest. Initially, I assign the value for ALS. Here, I assign the value of ALS 0, 0. In the program, in the initial state, I assign the highest value parameter as 0, 0. This 0, 0 will be assigned to AL register. If you use move AL comma highest, now the value for AL here is 0, 0. This instruction is used to compare the value for AL to the used to initialize the register AL. Initially, it will be 0. Now to initialize it to 0, I assign the value for parameter highest to 0 here. Then compare AL comma SI. After assigning the length of array to CL register, AL register to 0, 0, and data segment pointed by SI register. This will hold all the six values, 8-bit values. After that, we will need to compare AL value with SI register one by one. If after comparing means by simply subtracting the AL register value with the SA register value. If you subtract lower value with the higher value means there is a presence of carry. If carry is present, simply copy the value of SA to the AL register. So if you compare a higher value with lower value, there is no carry. If no carry means just hold the previous value as it is. You need to compare one by one like this way. Compare 40 with 30. 40 with 20. Comparison means by simply subtract. Okay. Compare AL with SI, and the result will be stored in the AL register. Now see the value for AL register. If condition, check the condition here. Jump with no carry. No carry. If no carry is produced. If no carry means just to move to the subroutine, escape P, skip to subroutine. Increment Si, decrement Cl. Okay. So after comparing this number with this number, if no carry is produced, just simply increment Si value and decrement the Cl register. If carry is produced, what will happen? If carry is produced, it will not execute this condition. If no carry, if sorry for example, sorry if no carry, it will be moved to the skip to instruction, simply incrementing Si, decrementing Cl. If carry is produced, it will move the value of Si to the Al register. Okay, see the first number here, Al is smaller, Si is bigger. If you subtract zero lower number with the higher number, there is a presence of carry, that means borrow. What we will do is simply move A comma Si. What it will do, it will simply move the value of Si register to the AL register. See here, 40 will be to the AL register. And then increment Si, decrement Cl. So Si will be incrementing to this address location, and Cl will be decrementing from 6 to 5. And then it will compare the next data with the AL register, 40 with 30. If carry is produced means simply data from this to this. If no carry means just increment Si and decrement Cl 5 to 4 and do comparison. Finally, you will get the highest value the AL register. What is the highest value? This is the concept here. Increment Si, decrement Cl. It will check for condition after comparing all the 6 numbers. Now this condition jump no zeros. No zero means it will check Cl is equal to 0 or Cl is not equal to 0. After comparing all the 6 numbers, what is the value for Cl now? 0. Cl will be 0. Check condition here, jump with no zeros to back to. It will not move to back to. It will not compare the number again. If Cl goes to 0. After comparing the 6 numbers, the counter will goes to 0. It will not go to the compare instruction. This condition fails. What it will do? Simply move the value of Al to the highest parameter. Now the value for highest here is highest value is 40. It will simply move value of Al to the highest parameter, highest input parameter. These are all the instructions how to get highest values from the series of numbers. Okay, the concept is clear. This is very important. If carry is produced, simply copy Si to the AL register. If no carry is produced, that means after subtracting the AL register value with Si, if carry is produced, just simply copy the Si to the AL. If no carry, simply increment Si and the decrement counter and compare the value of Si with the AL and check for carry. And okay, carry, simply copy the AL. If no carry, just to hold the previous value of AL to the next comparison. That is the mean. So next here is to find the smallest number. Okay, the logic first here is compare AH register value with Si register. In previously we compare Al with Si. To find smallest number, we need to compare AH register value with Si register. If no carry, copy Si to the S register to the Al register. If carry, increment Si and decrement Cl. Okay, I use these two different concepts to find the smallest number in a series. Okay. First, you know very well these two codes, move AH,09, LEA, DX, SH1, INT21. This set of codes is used to display the strings in the output window. strings in the output window. That means if you want to message one is enter the numbers. User enters one by one, six different numbers one by one. Now to display the numbers, enter the number string in the output window. We use these codes. Just for the INT21 video lecture, I explained these three different lines. These three different lines will help you to display the string on the output screen. For example, if you want to display, enter the series of numbers to find smallest number. That string you will need to display in the output screen. For that, we use this set of codes to display the strings on the screen. Similarly, call ek get 8. This is the function we use to get the numbers, 8-bit numbers, one by one from the users. This will go to the this instruction. I already told program how to get 8-bit numbers one by one from the users through keyboard. It will move to the ek get 8 function. Ek means EKE department. Get 8 means this will help you to get 8-bit data from the user. If user enters 8-bit number, but user gives only the ASCII equivalent. To convert the ASCII equivalent number again back to the original number, we use this set of codes to get the values from the users. After getting the 8-bit, after converting the ASCII number again back to the original number, we will assign the result to the 8-bit number to the AL register. After assigning the number to the AL register, this will give the value of AL to the program. Now the value of AL is 8-bit number, some 8-bit numbers. This will be moved to the SA register. I already told SA register is a array. It will show the number one by one, like previous concept. It will simply increment and decrement here. This will add all 6 numbers. This will help you to add and store 6-bit numbers one by one from users. Okay. I assign length of the array is 6. It can able to store 6 numbers, 8-bit numbers one by one into the array. I assign the parameter lowest. It's a simple parameter. I hold the value as FF. For comparing the highest number means I hold the highest parameter as 0, 0. To get smallest number means I assign the lowest parameter as FF. To compare the value of AL with SA. Okay. Now we go to the program here. Calculation. This will help you to calculate the smallest number in a series. LEA means load effective address SA, array. This will load the offset address of array to the SA register. This will help you to load the offset address. Offset address means memory locations in the data segment. SA is a register. SA is source index register. This will hold all the address, offset address in the data segments. So after adding each numbers in the array, SA will be moved incrementing one by one. After adding first number, it will goes to next location and store second data. So after adding second data, this pointer will be moved to the third location, store third data. If you add fourth number means SA will be moved from third location to fourth location. So in order to point out all the address locations in the data segment, I assign the value for array to the SA. This will simply copies the offset address of array to the SA. LDA stands for load effective address. Load effective address. That means simply assigns the offset address of array to the SA. And move CL comma length. Length here is 6. That means CL is a counter. This will load. This will hold 6. It will count 6 different numbers. For each comparison, counter will be decrementing by one value. See here, I assign the length of the array as CL. After each comparison, that means AH register value with the SA register, the counter will be decrementing one by one value. For first comparison, counter will be decrementing by one value from 6 to 5. Second comparison, counter will be decrementing by one value. Then 4 to 3, 3 to 2, 2 to 1, then 1 to 0. Counter value will be decrementing and SA register. This first it will point the first address location. After comparison SA with the AL, SA will be incrementing. For example, this is the first address location. Next comparison, this will be moved to second, then third, fourth, fifth, sixth address location. Simply increment SI, then decrement CM. For each comparison of register AH register value with SA register value. Now the concept I will tell here. Here move AH comma lowest. What is the number I assigned for lowest parameter here? FF. So now the value for FF for lowest parameter, that means FF will be moved to the register AH. Assign the value for register AH as initially FF to find the smallest number in a series. First compare that. First compare. What is the instruction? This is the instruction we used to find the smallest number. Previously, this instruction to find largest number. This instruction we used to find smallest number. First compare AH register value with SI register. See here, initially AH is FF. Compare this value with this value. AL is more than SI. FF is more than 40. See here, condition is compare AH with SI. If no carry, simply copy SI with AL. If carry means increment SI and decrement CL. Compare, if you subtract, compare means subtracting. Subtracting. Simply subtract higher number with lower number. Uh, what will happen? If you subtract higher number with lower number, there is no carry. If no carry, copy the value of SI to the AN register. This value, the number assigned to the SI will be copied to the AN register. Because here, no carry. Because you are subtracting the higher number with lower number. If you subtract higher number with lower number, there is no carry, there is no borrow. Simply compare the value of 40 to the AN register. Next, compare second number. 40 AL with SI. For AL is greater, SI is smaller. If you subtract higher number with the lower number, what will happen? There is no carry. There is no carry means copy SI to the AL. Just simply copy the value of SI to the AL register. Compare 30 with 20. AL is greater, SI is smaller. If you subtract higher number with lower number, no carry. If no carry means simply copy SI to AL. Simply copy SI to AL. Then compare 20 with 10. AH is higher and SI is smaller. If you subtract higher number with lower number, no carry. Just simply copy the SI to the AL register. Then compare 10 with 9. So 10 is higher, 9 is lower. If you subtract higher number with lower number, no carry. Just simply copy the SI value to the AH register. And compare 9 with 80. AL is smaller and 80 is higher. So if you subtract smaller number with higher number, carry is produced. So if carry is produced, simply increment SI and decrement CL. No need to copy this number to this number because carry is produced. No need to copy SI to AL. So the program terminates. Now the value for CL is 0. This is the lowest number. Compare 40, 30, 20, 10, 9, 80. 9 is the lowest. Finally, the lowest number, the smallest number will be assigned to the AH register. Okay, this is the concept how to get lowest number in 8086. See the instruction. Compare AH with the SI. Compare A with SI. So if no carry, copy SI to AL. If carry means increment SI and decrement CL. Jump, it will check with condition. JC stands for jump if carry is produced. JC means jump if carry is produced. See here, if you compare, if carry is produced means what will happen? It will move to the skip to subroutine. Just simply it will increment, decrement CL, and it will not copy the value of SI to AL. It will not execute this instruction. It will not copy the value of SI to AH. When the value of SI will be copied to AH, if no carry is produced, SI will be moved to AN register. If this condition fails, this will copy the value of SI to AH register. And after copy the value of SI to AH, this will simply increment SI and decrement CL, and this will compare the next numbers one by one. So for each comparison, the SI will be incrementing because SI will be incrementing, CL will be decrementing. That's why I mentioned increment SI, decrement CL, and it will check for conditions. Jump with no zeros. Put back to subroutine. When this condition fails, once the CL goes to 0, after comparing all the 6 numbers, CL goes to 0. So this condition fails. This will not go again back to the this instruction to compare the second series of numbers with AH with SI. So after comparing all the six numbers, see now the CL goes to 0. So this condition fails. This fails. This will move to next instruction and load the value of AH to the lowest parameter. Here the lowest number we got after comparison is 9. This will be moved to the parameter lowest by simply using this instruction move comma lowest my AH mean. This will simply copy the result after comparison to the lowest parameter. You will get the result as 9. It may be any number. Here in the series, the lowest number is 9. So finally, after comparison, AH hold the lowest number. This will be moved to the parameter lowest to find lowest one. I hope the concept is clear how to find highest number, how to find lowest number by using this set of logic. This is the instructions we will need to use in 8086 to find largest as well as smallest number in 8086. This is the program to find both largest as well as smallest number in a series. I just combining the concept of to find highest to find lowest. Here, see here, move CL comma length. This will put the maximum value. I assign the AL register to highest and AH register to lowest. I do comparison AL with SA, and this step is for to find the this instruction is used to find largest number. See here, AH compare AH with SA. This instruction is used to find smallest number. Here I combined the program for to find both largest as well as smallest, and I included in the program code. Okay. This is the full program to find largest and the smallest. Just try this program in simulator EMU 8086 and check for outputs. I enter all these values one by one. This instruction you all know very well. This move AH, 09 LEA DX, message 1 INT 21. This instruction will help you to display the first string, and the MSG1 means this will check for message 1, and this will display the first string in the output window. Similarly, this instruction is used to display the second string 8086 practicals. This instruction will help you to display the string, this dash. This message 4 will help you to display the string to find largest and smallest number in a series. Finally, message 5. This will give some spaces. I discussed how to do. This one is to get 8-bit number one by one. This instruction is used to find largest and smallest. I explained just now. Just first enter this code, then enter this set of codes to find largest and smallest. Then you will need to enter. This code is used to get 8-bit number from users, from keyboard. This set of instruction code I explained one video separately. Just to see the video, what is the function for EK get 8? This function will help you to get 8-bit data from the keyboard from the users. After getting data, this will be assigned to the AL register. This value will be used to find largest and smallest number. This will be moved to AL register, and it will load 8-bit data one by one to the array. After loading all the data, we will go for comparison to find highest and lowest number. Okay, the concept is clear to you. Just enter this program first, then these lines, then these lines. So after entering these set of codes in the simulator, you will get the output. Now I will show how to get the largest and smallest numbers. And in simulator, I enter these programs in simulator. Simulators are already entered. Now I will show how to check for lowest and smallest number in a series. After simulation, I go for run here. First it will display Masaram University Angapuram 8086 practical to find largest and smallest number in a series. First I enter 1, then I enter 2, 3, 4, 5, 4, as well as 6. These are all 6 different numbers. Uh, After entering these numbers, I will get the output which number is largest and which number is smallest. See here, there is no error. Now I check for output. Click the varies. See here, there is a mistake here. I will check one more time. 10, 11, 12, 13, 14. I entered 10, 11, 12, 13, 12, 15. Now I check for output. See here, entered array as 10, first number 10, second number 12, third number 12, 13, 10, fourth number, fifth number 12, sixth number 16. The highest number is 15 here and lowest number is 10 here. This is the way how to write program to find highest and smallest number in each ranges. I hope the concept is clear to you. If you have any doubt, just simply comment in the chat box and in the comment box I will explain you. Thank you everyone for watching. I will upload this set of more videos on my channel. Kindly subscribe and watch.